Hello, my name is Rafael. I'm a fifth year PhD student in electrical engineering. I'm working under the supervision of Dr. Edgar Lobaton. And today I'm going to present the work that we developed within the Active Robotic Sensing Laboratory and Engineering Building 2, which is a feasibility study of water stress detection in plants using a high throughput, low cost system. So let's start talking about the motivation behind this work. And that relies on water management, because we're concerned with offering the best management of water in crops. We want the best level of water management possible, and thus ideal water management enable optimal crop development, and that implies high yield. So identify a water deficit early or before it is visually apparent. This visual trait can allow measures to reduce the impact of water deficit. So our proposed work, we developed a system capable of acquiring a high volume of images, as you can see in the video on the right. Most part of the state-of-the-art rely on a IR measurement or sophisticated hyperspectral or thermal sensors and camera. So the system is intended for ground level measurements and more accessible equipment. So we're looking for a cheap solution. We want to make a proof of concept for identifying early water stress with a low-cost equipment. Okay, so let's talk about the high-throughput data collection system. The system relies on a near-infrared NIR camera covered with a blue light film filter. The near-infrared light spectrum is a spectrum of light that allows us to see things, properties from the plants that we normally couldn't see with the naked eye. And everything is controlled with a microcomputer. So as you can see here, in the video demonstrating the setup, we have a horizontal degree of freedom and also a vertical degree of freedom. The blue box here represents the no IR camera, which is a near-infrared camera that is placed here. And on the top, this green box represents the Raspberry Pi that is right here on this card. At letter C, you can see how we place the plants in front of the camera. Letter B shows a sample of how the pictures look like. And then we have the setup. So let's talk about the visual phenotyping approach. So we basically take images from the plants. The NGB image is the original one, and we take only the channel related to the near-infrared light spectrum, which is this one right here, and we convert that to a color range that enables us to remove the background easily. With this color range, we're able to build this binary mask, which is basically a picture that we have white pixels and black pixels. And whatever is black, we will remove out. So that's the way we remove the background of the image. And that becomes a mask that we can apply back to the channel related to the near-infrared image, such that we remove completely the background and we're just left with the plant itself. Then on top of this masked image, we attribute a pseudo color range images that will display the places of the plant that has higher reflectance of near-infrared light. And with that, we can infer the health status of the plant. And you can see that using this technique, we're able to identify the water deficit condition. So we're able to identify before the condition becomes visually apparent, showing that near-infrared light is useful for this purpose. Alright, that's it. Thank you.